So Samsung is introducing a new smart SSD with an AMD Xilinx FPGA on it. So this is pretty interesting. Basically, what this will do is the SSD is going to be able to process data right on itself, and that's going to be very useful for a few reasons, and also not useful for many other reasons. So usually how it works, you have your SSD and you have your CPU, and your CPU is going to request the data that it wants from the SSD, and then SSD will usually send that data into RAM, and then from the RAM it will go into the CPU cache, and then the CPU will do some stuff, it will do some work, write it back into its cache, and then usually it will even go back into the RAM and back into the SSD. Now, that takes a lot of time, obviously, right? There's a lot more latency. I mean, just from the actual length of the paths that the data needs to travel, there is some latency. You know, like electricity is super fast, about 90% the speed of light, but of course there is some extra latency. You know, if we take motherboards for example, you have your CPU and then you have your RAM slots. Why don't you have your RAM slots like down here? Well, because then it would be like further away, there would be more latency. So does this kind of make sense? Hopefully. So these devices will be able to just process stuff right on them. You know, it's a storage device and it will be able to process its own data right on the device, making it faster. Now, will this make your games run faster? No, this will probably not make your games run faster. But the main reason these exist is to help use cases like databases and stuff with frequently accessed data, right? And like maybe, you know, you have a server that does transcoding, maybe it can be done right on the drive. It's not going to have to be fed into the CPU and stuff. And you legitimately, you know, Samsung promises 50% reduced computational times. You know, of course, you're cutting down a lot of latency, lower power consumption, less CPU utilization, you know. So this is an interesting one. So if you're just a normal consumer, you might not know this, but sort of transferring and reading and writing data, it's actually pretty intensive when you're dealing with really large amounts of data, you know. So to just put it into perspective, a few years back I had to make a database and then I had to fill it with a whole ton of data. It was Excel spreadsheets to be very specific, you know. But there was like 25 gigabytes of Excel sheets, you know, like that is a lot of Excel sheets, right? And what I noticed when I started filling the database, I was on my old 4-core 4770K back at the time, but I already had a nice NvMe PCIe SSD, the Corsair MP510 to be specific. So a very nice high-end SSD, right? So when I opened Task Manager, I was kind of surprised to see that my CPU was totally maxed out and the SSD was sort of just chilling because the CPU was the bottleneck. So for use cases like that, this makes a lot of sense. So is this going to make a lot of sense for normal consumers? No. Are normal consumers going to get it at some point in the future? Probably. I mean, because, you know, these sort of processors, these FPGAs and stuff will probably just get so cheap that it'll just be another technology that's going to get thrown in, and it might help a little bit, you know. I mean, depending on what your workflow is, at the very least. So, you know, pretty cool, super impressive. This will mainly help like data centers and you know, use cases that just process a lot of data.